Is ice's specific heat capacity lower than liquid water's? Imagine holding a glass of ice and a glass of warm water. Which one do you think heats up faster? The secret lies in something called specific heat capacity. Let's explore what that really means for water and ice. Specific heat capacity is the amount of heat energy needed to raise the temperature of 1 gram of a substance by 1 degree Celsius. For water, this number is about 4.18 joules per gram per degree Celsius. That means it takes quite a bit of energy to warm up water. Now, compare that to ice, which has a specific heat capacity around 2.05 joules per gram per degree Celsius. That is roughly half the amount needed for liquid water. Why is there such a difference? It all comes down to how the molecules are arranged and how they bond together. In liquid water, molecules are packed close but are always moving and forming temporary hydrogen bonds. When heat is added, energy goes into making the molecules move faster and breaking those bonds. This process requires more energy, which is why water has a high heat capacity. In contrast, ice has a rigid crystal structure where molecules are held in fixed positions by stable hydrogen bonds. The molecules are spaced farther apart, and because they are locked in place, less energy is needed to increase their temperature. So, in simple terms, it takes less energy to warm ice than it does to warm liquid water. This difference helps explain why water can absorb or releases large amounts of heat without changing temperature much. It also plays a big role in Earth's climate, helping water bodies moderate temperature swings. To sum it up, yes, ice has a lower specific heat capacity than liquid water because of its stable, crystalline structure. The molecules are less free to move and absorb energy, making ice heat up faster than water. This property is fundamental in understanding how water and ice behave in nature and in many scientific processes.